Section 10.7 is proving angles congruent. Our goal is to prove and apply theorems about angles. On page 636, we have in the Solve It, you may have noticed a relationship between vertical angles. You can prove that this relationship is always true using deductive reasoning. A theorem is a conjecture or statement that you prove true. You can use given information, definitions, properties, postulates, and previously proven theorems as reasons in a proof. So theorem 1, we have vertical angles theorem. Vertical angles are congruent. So in the diagram, angle 1 is congruent to angle 3. Here's angle 1, here's angle 3. We've previously learned what vertical angles are. And we also have vertical angles with angles 2 and 4. So angles 2 and 4 are congruent. When you are writing a geometric proof, it may help to separate the theorem you want to prove into a hypothesis and a conclusion. Another way to write the vertical angles theorem is if two angles are vertical, then they are congruent. The hypothesis becomes the given statement, and the conclusion becomes what you want to prove. A two-column proof of the vertical angle theorem follows. On page 637, we have the proof of theorem 1, vertical angles theorem. So given angles 1 and 3 are vertical angles, we want to prove that they are congruent. So we start with our given statement. Angle 1 and angle 3 are vertical angles because this is given. Next, we can say that angle 1 and angle 2 are supplementary. Here we have a linear pair from angles 1 and 2. We also have a linear pair from angles 2 and 3, so we can say angles 2 and 3 are supplementary, and that is because angles that form a linear pair are supplementary. Using the fact that the sum of the measures of supplementary angles is 180, we can say that the measure of angle 1 plus the measure of angle 2 is 180, and the measure of angle 2 plus the measure of angle 3 is 180. So we know if we add the measures of these two angles, we get 180, and if we add the measures of these two angles, we get 180 because they both form straight lines. Therefore, we can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. We are setting these two pieces equal by the transitive property of equality. Measure of angle 1 plus measure of angle 2 was 180, but 180 also equals measure of angle 2 plus the measure of angle 3, so we can set the two left sides equal. We can subtract the measure of angle 2 from each side to get the measure of angle 1 equals the measure of angle 2 by the subtraction property of equality, and then because angles with the same measure are congruent, we can now say that angle 1 is congruent to angle 3, which is what we wanted to prove. So we have finished the proof of the vertical angles theorem. Example 1 says, what is the value of x? Notice that these two angles drawn in the diagram are vertical angles, so we can say that the measure of this angle is equal to the measure of this angle. This problem just asks for the value of x. It doesn't say to justify every single step, so we don't need to write them out, but we can still justify them verbally by saying that these were vertical angles, so their measures are equal. If we subtract 2x from both sides, we get 2x minus 2x, which is a zero pair, and this leaves us with 21 on the left. 4x minus 2x gives us 2x. Now to get x by itself, we can divide both sides by 2. 2 divided by 2 gives us 1, so we have just x on the right, and 21 divided by 2 is 10.5 if you want to write it as a decimal, or just 21 over 2. The work for this problem is written out on the next two slides. And now I would like you to try homework number 1 and 2 on page 637. Find the value of each variable. For number 2, we have find the measure of the labeled angles in exercise 1.